Hey, this is Dr. B, and here's a couple of things about ions. One thing about them is they're not always from single atoms. They can be polyatomic. Oh, sodium chloride, each ion is derived from a single atom. But consider this rock here. This rock is limestone. The chemical name is calcium carbonate, or, if you will, chalk. The charges on the calcium cation are +2. The carbonate anion, which you can find on a list such as this, for example, is -2. Therefore, they offset nicely, and we can simply write CaCO3. The polyatomic ion in this case is the carbonate anion, or sometimes called the carbonate dianion, since it's -2. There's lots of other examples. Here's a simple list. Most instructors provide lists to their students. Maybe they make them memorize them. Sodium cyanide is an example of a ionic compound with a polyatomic ion. In this case, cyanide is Cn-1. Therefore, NaCN fits nicely. Calcium hydroxide would be another example where hydroxide is the polyatomic ion and it's -1. But in this case, since calcium's +2, we need to write it like that. You can either do it the fast way and switch the charges. In other words, write a little 2 here and write a little -1, or just skip the minus, since when you switch them you're going to drop it anyhow. And the 2 goes there and the 1 goes there. Or think it through. That 2 plus and that 1 minus do not offset each other, but they do if you have 2 hydroxides. Another thing about ions is that they can have multiple charges. In other words, they can be polyvalent. Consider the titanium atom. Its configuration of those 22 electrons is shown here. 1s2, 2s2, 2p6, 3s2, 3p6, and focus on these last two, 4s2, 3d2. Okay, that third shell there is unfilled. It can hold up to 10 electrons, but it only has 2. That's an unfilled inner shell. That's a little bit unusual. This is the case for nearly all the transition metals in the center here. And so look how many of them are polyvalent. They can exist with multiple charges. For example, if this were to be 4s1, 3d3, it might have a different charge. And in fact, you can, under the right conditions, get these things to have multiple charges. So it's due to the unfilled inner shells that leads to close energy levels, which in turn leads to multiple electronic configurations. So let's do a few. They solve this, by the way, by simply, and this is important, including the charge using a Roman numeral. That's a nice system because you throw it right in there. Here's an example. Titanium 4 chloride, well, that's telling you titanium's +4, where you write TiCl4. The same stock room might have TiCl2. That is titanium chloride, but of the 2 variety, 2 different substances. It's polyvalent. Iron 2 cyanide means that form of iron cyanide where iron is +2. Since cyanide's only -1, we better write it using parentheses. And let's quickly avoid a common error. Sodium chloride, what's its name? Many students at this point say sodium 1 chloride because they start throwing in these Roman numerals. When to throw in the Roman numerals? Well, that's a little bit difficult to answer because it's going to vary from instructor to instructor. The technical answer is you should really do it anytime it's multivalent, but some of them are obscure, rare, recently discovered, things like that. So typically do it for most, if not all, of the transition metals and perhaps some of the common ones. If you have a kind instructor, he would provide a periodic table of ions such as this so that there is no ambiguity. That's a couple things about ions.